word that we like to use. Okay? I don't think we like to use the word congruence. Okay? But we like to say that these things are the same. Alright? We like to say these things same as that one. Alright? Everything also same. Okay? But what is the meaning of same? Okay? Are you all the same? Are these triangles here all the same? Okay? It is subjective, right? Because maybe, okay, Zach, we think that all these triangles, yeah, they're all the same because they're all triangles. Alright? Okay? Then after that, maybe common things differently. They're not the same because B is obviously bigger than the rest. Okay? So talking about size instead. Right? So we have a different definition about this idea of sameness. Okay? And we want to draw a distinction between what is considered the same and different. Okay? By being very clear about this idea of sameness. Okay? That's why we introduce the word congruence and similarity. In fact, in the English word itself, we may think that the word similarity is actually synonymous, meaning to say they are of the similar meaning to the word same. Okay, so what exactly is congruent? Okay, so in mathematics, to define about congruent, we're looking for the same triangles. Out of all these triangles, just by the look of it, can you tell me which are the same to you? Okay, anybody say M and D right here? Rose say M and D are the same to her. And then Nancy says M and D or M and D. Okay? M, B and D. Okay? They all look similar because they are triangles. Okay? So this idea of congruence, the way we define it in maths, is that congruent figures have the same shape. So we have a thing to be specific about. Must be of the same shape, or they are all triangles. Okay, but very importantly, same size. Right, so that is the meaning of congruency. So they must be same shape. So if we're talking about triangles, they must be triangles. And then same size. Now what does it mean by same size? Okay, looking at this diagram over here, which one will you say is the same size? M and D. They look and appear to be the same, right? Okay, so if I were to do my rotation, actually A and M are the same. Okay, I actually match each other. See? Okay, so just that we have our reservations because of the orientation of A itself. We cannot quite compare that easily. Okay, and then furthermore, the differences in color. Okay? No, I didn't make it so I made it a little bit bigger. It is exactly a rotation. Okay? Then after that, M and D itself are actually of the same shape and size also. Okay? So actually A and M and M and D, they are of the same size and same shape, and they are actually the congruent. Okay? So when we say that something is congruent, so you see just now when I mapped it, right? Okay, we observe that we want to be very precise about this idea of same size. Okay, so when we say same size, we're actually referring to equal corresponding length. And also equal corresponding angles. So these are what we are looking out for when we say that they are of the same size. Okay. Now what do I mean by corresponding? That means that earlier on, comparing let's say M and D, if you're looking at this angle over here, it is actually equal to this angle over here. And then this angle over here is equal to this angle over here. And over here, the last one is equal to this. Okay, so that is how we see corresponding. Right? But in our examples, usually there is a certain naming for our figure. So for example, let's say maybe quadrilateral. I try my very best to draw something that's congruent. Okay, let's say I name this A, B, C, D. Okay, and then I name the other one as W, X, Y, Z. I can say that A, B, C, D is congruent to W, X, Y, Z, but I cannot say that A, B, C, D is congruent to W, Z, Y, X. Okay. In a match statement itself, I can phrase my sentence in this manner. The triad over that side, Asher, Faith, and Zayden want to continue conversation outside. Okay. So we say ABCD is congruent to WXYZ, but I cannot say ABCD is congruent to WZYX. Why? It is because when we name things, we must ensure that it is corresponding. So from the figure itself, we see that A corresponds to W because the angle here will be equal to this angle over here. Okay? While for B, it must correspond to X because we know that if let's say these two are congruent, this angle over here and this angle over here, they are equal. Lastly, then after that, we also have C and D that corresponds to your Y and D corresponding to Z. Okay. Yes. I can't hear you. Sorry. Then you ask. Yes. Then you ask. Okay. So when you write a statement that says ABCD is congruent to WZYX, it is not true because your B itself does not correspond to Z. B being here, it does not correspond to Z. Okay? So the naming in the sentence itself is very helpful later on when we want to do any calculation. Okay? Because we can rely on the way that it is being stated in the question itself to help us do our calculations. Okay? So be aware about how the vertices, okay, the letters actually match with each other will be very helpful later on. Okay? So knowing this, we are able to very easily tell that things like angle ABC won't be equals to angle WXY. Okay? I can also say that angle CDA is equal to angle YZW. So I need not even look at the diagram. I can very easily refer to the way that it is stated to know. I can check angle CDA is referring to this. It is equal to angle YZW, which is this angle over here. Okay? So that is how we can identify which are the angles that correspond to each other, okay, through the naming, through the sentence itself. Likewise, when it comes to corresponding length, okay, I can say that BC from the naming is equals to XY. Okay, and then I can also say AD is equals to WZ. You understand? Okay, so these are just some examples that you can extract out of this. You may find that this is very simple. Why am I doing this? I can do this in primary school or even in kindergarten. Okay? In a standard question, definitely the diagrams given to you are not going to be side by side, okay, the same. Alright? You will see that the diagrams are going to be rotated, okay, flipped, right, in another form of transformation. Okay? So, time does my lesson. Let me take out the textbook, the equation. Since you don't have a textbook. Sorry, you will take more. referring to congruent. Okay, so that is a symbol to represent the word is congruent. Okay, so when we write ABCD, this symbol TQRS, we're trying to say ABCD is congruent to TQRS. Okay, so the word is congruent to can be using this equivalent sign, equal sign. Okay. So in this question, what we wanted to first find out in part I, they say PQ is equals to AB. We want to find out how many cm is it. And then SR is equals to which side? That is equals to 6 cm. PS is equals to which side? Which is equals to which cm? Okay, and then lastly the angle. So let's look at this diagram. Firstly, we have PQ equals to AB. So PQ is over here. Okay, they tell you already that it is equals to AB. In fact, we can also refer to this statement. We see PQ, AB. So how many cm is that? 5 cm, right? Okay. Part 2. SR is referring to this length over here. Which side does it correspond to for SR? Our CD or is it DC? It matters the way we name it. Although CD and DC seem to be referring to the same thing, okay, but we must ensure that the vertices actually correspond. So SR, if you look at this naming, SR, going back, it should be DC. So it should be DC and not CD. Okay? So we go in same sequencing. S first then R, so D first then C. Okay? Then part 3. We want to find which one is the corresponding side, PS. So PS is this length over here, going the way that it has been named, P first then S, so it will be equals to A then D. So we can see it very clearly that they are actually corresponding, and that is equals to 2 cm. Okay? And then in part 4, we have QR. So QR corresponds to what? What does QR correspond to? BC, right? Okay, so we look at the naming. Q first then R, so B first then C. And BC is actually equals to 5.3 cm. Right? What about the angles? Okay, angle PQR is this angle over here, which is 90 degrees. Okay, you can also refer back to this naming. PQR, so going by the same sequence, it will be ABC. So it is equal to angle ABC, which is 90 degrees. Okay, any questions? Right? Congruency is really a straightforward thing. Okay, usually not so much of a challenge. Right? However, later on when we go into set 3, we are going to learn how to prove whether two things are congruent to each other or not. Okay? But I will continue with this on Friday. So on Friday, please bring your volume B textbook. Okay, so this is what we understood about congruent figures the other time. Okay? So we take a look at practice now 3. Okay, so the other lesson we have already identified how to determine the length itself. Looking at your textbook page 8, the question is asking whether the triangles shown are congruent or not. my inaccurate drawing on the whiteboard, are these two triangles considered congruent? No, right? Because why? Clearly not the same size. Okay, but how do we actually explain it emphatically? Okay, so we can say that triangle ABC and triangle PQR are not congruent. Okay, because the corresponding sides are not equal. We have 40 degrees, we have 60 degrees, and we also have 80 degrees. Okay? But having angles to be corresponding to each other and equal to each other, okay, does not necessarily lead to the triangles being congruent. Okay? So in congruency itself, in fact, to be very certain about it, we need to check that the corresponding length sides are actually equal to each other. Okay, so having equal angles, equal corresponding angles, does not necessarily give us in return congruent triangles or congruent shapes. Okay. For part B, rather than saying that they are safe. Okay, be very precise. Okay, to tell me that the values are ways of proving that two triangles are going to be congruent. So actually at this juncture, I want to share with you that it is already sufficient for us to claim that the corresponding length of the sides are equal. You don't need to go and mention about the angles. Okay? So that is what we will be learning at Sec 3. Okay? You will learn that one of the tests that we can use to run, okay, is that the corresponding length of the sides are equal and is sufficient already. But of course, we need to write down the steps. Okay? This statement itself is not going to be sufficient. Right? This is the conclusion of it. So how the working will be like? Okay? We need to identify which are the corresponding sides. So we have this 4 cm side and this 4 cm side over here. So we say that DE, okay, is equal to ST. Am I right to say that? Remember about the vertices, they need to be corresponding. Okay? D needs to correspond to S, E needs to correspond to T. But is that true? We look at the angles. DE is our 4 cm. D has an angle of 80 degrees. ST, okay, is 4 cm also. But S, if it corresponds to D, the angle here needs to also be 80 degrees. Agree? So we see that down here is the one that is actually 80 degrees. So we observe the angles to help us know how to make sure that the vertices are corresponding. So it is actually DE equals to TS, that is equals to 4 cm. Okay, so there is one pair of corresponding sides. We have other pairs of corresponding sides. The next one, maybe we look at the 6.13. We have EF over here. Okay, we see in the other triangle we have 4.13 over here. So EF corresponds to what? Is it SU or US? What do you think? How many of you think that it is SU? Okay, who thinks that it is US? It is, what do you think? SU, okay? So for the value here is not calculated. Actually, we can do a very good calculation. 180 minus 80 minus 60, we know down here will be 40. Okay? Likewise, down here will be 60. Because angles are of triangle. Right? So EF will be equals to SU equals to 6.13 cm. And then lastly, the side that is 5.39, we have DF. So DF will correspond to TU. Okay? So we have TU over here, and there is 5.39. Okay? So to complete this statement that Blake has given us earlier, and we have improved on it, we say that since the length, the corresponding length of the sides are equal, triangle DEF, okay, make sure we match the vertices. So DEF, so D was corresponding